welcome to our today's lesson where we'll be solving an exam question which is under blood flow. Okay, the question that I have here is very simple. So the question reads, blood flows in an artery which is about 40 milliliters of diameter and viscosity of 0.02. The blood is moving with a rate of 1 liter per second. So this is the statement of the question. Now the question itself is saying, is the flow of blood, of course, laminar or turbulent? This is the question. Is the flow of blood laminar or turbulent? So in short, what they are saying is, this blood is moving in this artery. Okay, so this is the artery, and of course we know the only artery that is of course having closer the diameter of 40 milliliters is of course the aorta. So this blood is moving in this aorta, and what the question is saying, is it flowing laminar or turbulent? So for us to state whether it is flowing laminar or turbulently, we have first to calculate for Reynolds number. So what laminar means, it means that the blood will be flowing quietly and in the same direction, okay? In the same direction. That is the what? Laminar flow of blood. But when we talk about the turbulent flow of blood, it means the blood will be moving in all the directions. It can either move in this direction, that direction, yeah, more like uncontrolled. And of course, it will be making noisy, okay, as it is flowing. Yeah, it is not quiet. So now here, let us try to solve for the Reynolds number so that we can tell whether this blood is moving laminar or turbulent. So the formula that we use to calculate for the Reynolds number, so Reynolds number, it is given by, okay, so this is the formula that we use, the density multiplied by the velocity, then multiplied by the diameter. So this is the density of blood, then velocity of the blood, and the diameter of the vessel where the blood is moving in. In this case, it is where? In the artery. Then divided by the viscosity, okay, the thickness of that blood. So this formula is in general, you can even use it whether maybe you are calculating for the Reynolds number that is of course in the pipe. Yeah, maybe the water is moving in the pipe. It's the same formula that we use. So here, what do we have? We consider now what we have here. So density, do we have the density? Have we been given the density? No. So meaning we're going to use the standard density of what? Of blood here. What of the velocity? Have we been given the velocity in this question? No, we haven't been given the velocity. So we are also going to calculate what? For the velocity. So we're going to use the other formula for calculating what? Velocity. But the diameter, yes, the diameter we've been given is 40 milliliters. And of course, the viscosity of this blood we've been given is about 0.002. Okay, so let us first put what we have here so that we see what we are not having. So the density of blood, it is of course thicker and denser than what? And water. So we know to say the density of water is about 1000, that is of course kg per cubic meter, per meter cube. So now this is the density of water, the standard. And of course for blood, it is 1060 kg per meter cube. Okay, so this is the standard. It is denser than water because of the red blood cells, the platelets, yeah. So now, here, what we're going to use for density of blood, we're going to use this number here that we have, which is 1060. So 1060, which is the standard. So 1060 kg per meter cubed. So that is what we're going to use. What of the velocity? Have we given the velocity in the question? No, we haven't given the velocity. So we're going to solve for it. So velocity we don't have. What of the, this is the diameter. So the diameter of the artery that we're talking about here, yes, it was given in the question. It is about 40 milliliters. So now, 40 milliliters. But you have to know that we have to be converting these units in their SI units. So that is the density. So the density we've been given is about 40 milliliters. So converting this density into the SI units, we just divide by 1000. So it will be 40 multiplied by 1000. We are having 0.04. What do I have here? It is 0.04 meters. Of course, that is the diameter of this vessel or an artery. What of this one? The viscosity, yes, the viscosity we were given in the question, it is about 0.002. Okay, that is of course kg per meter per second. Okay, so this is the viscosity of what? Of blood. So now, if we compute everything that we have here, it means we won't solve this question because there are some values that we are missing here that we don't have. Okay, so which is what? The velocity. So let us start by calculating for what? For velocity. So we are going to use the formula for what? For blood flow. Why? Because the flow is given in the question here, which is 1 liter per second. So this 1 liter per second that we are seeing in the formula, it is what? The flow of blood. So meaning the flow is given by 1 liter, 1 liter per second. Okay, that is the flow of blood. So the formula that we use to calculate for flow of blood, it is given by, since the velocity will be given by the flow of blood over the cross-section area of where the blood is flowing in. This is the formula. So now this is the flow of blood. So making the flow of blood the subject, we're going to have flow of blood will be equal to the velocity at which the blood is moving at times the area, the cross-section area in which this blood is moving in. So this is the cross-section area. So this is now the formula that we're going to use. Do we have the velocity? No, we don't have, because this is now the one that we are solving. The flow, yes, we have. What of the area? So the area, we want to say the area is given by pi r squared, and we have the diameter there. So meaning if we try to have the diameter that has been given in the question, we're going to find the what? The radius. Okay, so this is very simple. This is what we're going to use, this formula. So here, let us try to compute now. Velocity, we make the velocity the subject now. We're going to have here, it is over the cross-section area, even here over the cross-section area, meaning this area will divide with this area. We are having velocity will be now equal to flow of blood over the area. Okay, so here the formula that we have now, it is velocity will now be equal to flow of blood over the cross-section area. Okay, so that if we compute here, we find for velocity, we will now going to get the same value that we're going to find here and put it where? Here, so that we solve for Reynolds number. Because remember, Reynolds number, it is now the number that will give us, of course, the correct thing here. Description about what? The flow of blood, either laminar or turbulent. Yeah. So we're going to use this formula here. So we're going to say velocity. So here we're going to say the velocity now will be equal to the flow of blood we are given. It was what? 1 liter per second. Okay. So now if we try to convert this, we know that 1 liter per second is not the standard. Okay, it is not in its standard as a unit. So meaning you have to convert, because the flow of blood is given in what? In centimeter cubed. Okay, centimeter cubed, like that, per second. That is now the flow of blood. It is given in this unit. So meaning, again, we have to divide that 1 liter by 1,000. Okay, so dividing that by 1,000, or here you can even solve it in what? In meters per second cubed here. Yeah, so we're going to say 1 divided by 1,000, I'm getting 0.003. Okay, so what I'm getting here, it is what? 0.003. Okay, so now this 0.003, it is the what? It is not the velocity of the blood, but it is the flow of blood. So this flow of blood that we have here, it is the what? It is 0.003. So velocity will be equal to that divided by the cross-section area, which will be given by pi r squared. So here we're going to say pi, then where there is r squared, we're going to put the value for diameter, which we are given in the question. So the diameter was given by 40 milliliters, and of course we have to convert it into what? SI units, which was 0.04. So using 0.04 here, we're going to say 0.04, but remember this is the diameter. So for us to solve correctly this one, we have to divide it by what? By 2, so that we're sure to say we are using what? Radius here. Okay, of course we are using the diameter, but if we divide it by 2, it means we are solving for what? Radius. So like that, but of course squared. Okay, so area will now be equal to try to compute this, we're going to have, so 0.04, so you say 0.04 divided by 2, you're going to have 0.02, then squared. So if you square this number, 0.02 squared, okay, what you're going to have now is 0.004, okay, 0.0004, okay, 0.004, like that. So this is now the value that I'm having for what? For this part. But if we try now to multiply it with this pi, what are we having? So multiplied by pi, I'm having 1.25, okay. So that is the value that I'm having. So now try to computing this at once. We're going to have, so pi, open bracket, then we say 0.04 divided by 2, then we close the bracket, then again we say squared. We are having, okay, so the value that I'm having here now for area, it will be 1.25 times 10 to the power negative 3. Okay, so this is now the value of what? The area, cross-section area that I'm having here. So what it means is this area, since we have the area here, we're going to compute it where? We put it here. And now we divide by what? By this. So that we solve for what? For velocity. Remember here, we are just interested in the what? In the velocity. So we are going to put this value of area that we have here, which is 1.25 times 10 to the power negative 3, like that. Then, if we try to compute this, what are we having? So it will be 0.003 divided by 1.25, then times 10, then times 10 to the power negative 3, we are having 2.4. Okay, so 2.4, it is now our velocity. Okay, this is now our velocity meters per second. So this is now our velocity at which this blood is flowing at. So we have the velocity here. We're going to put the velocity here in this Reynolds equation. Then we solve for what? Reynolds number. Okay, so just pretty sure to use the same space here. Okay. So here, Reynolds number will now be equal to what? So Reynolds number will now be equal to the density we said it is what? 1060. That's the standard of blood. 1060 multiplied by the velocity we said we calculated it was what? 2.4. So velocity we put it here, it was 2.4. So we're going to multiply it by 2.4. Then times the diameter. What is now the diameter of this vessel or an artery? It was 0.04 meters, 0.04 meters. If we divide this by the viscosity or the thickness of this blood, it was given by what? 0.002. So 0.002 kg per meter square, like that. Okay, so computing this now, what are we having? So it is 1060 multiplied by 2.4, then multiplied by 0.04. What are we having? So on top we are having 0.04. We are having 1000. We are having, so Reynolds number will now be equal to, so this is 101.76. We divide now by 0.002. Okay, so now dividing that, what are we having? 76 divided by 0.002. So I'm having 50,880. Okay. So here, the Reynolds number here, Reynolds number will now be equal to 50,880. Okay. So this is the Reynolds number. Mind you, Reynolds number doesn't have what? Units. So this is dimensionless. Okay. So the value will be equal to what? 50,880. So now, since we have solved for Reynolds number, so what will be our comment here? What will be our answer? Because remember, the question wasn't saying calculate for Reynolds number. It was saying, is the flow laminar or turbulent? But you can't tell when you're solving for what? Reynolds number. Okay. So now, what you have to know is, this Reynolds number, if it is less than, so if the Reynolds number is less than 2000, it means the flow of blood is what? It is laminar. Okay, so this is laminar flow, meaning blood is moving quietly and in the same direction. Okay, so this is the laminar flow. If the Reynolds number it is less than 2000, but if the Reynolds number happens to be greater than 4000, okay, it means this is the what? Turbulent flow, where now the blood or the liquid will be moving in a noisy manner. Okay, you don't be moving in a quiet manner. So this is what? The turbulent flow. So this is turbulent flow. If it is greater than 4000. Now, what if it is just in between 2000 and 4000? If the turbulent, rather, if the Reynolds number is between 2000 and 4000, it means now that is the what? Transition state or transition form. It means blood is now trying to move from laminar flow to turbulent flow. Okay, so if it is between here, what I mean is if this Reynolds number is between 2000, okay, so if it is between 2000 and 4000, 2000 and 4000, it means that is the what? Transition. So if it is 2000, okay, that is the Reynolds number, and of course 4000, so this is now the transition form or transition state of what? Of the flow of blood. Okay, so now let us try now to comment here using the number that we got, the Reynolds number that we have solved here. Okay, so here we have found to say the Reynolds number is about 50,000. Now, checking on the values here, is it less than or greater than 4000 and 2000? So it is of course greater than even for 4000. So meaning this is turbulent flow, okay, where now the blood will be moving. So if this is an artery, so if that happens to be an artery, it means blood won't be moving just in that direction. Okay, it will be moving this direction, that direction, that direction, and it will be moving what? It will be making sounds. Okay, this is turbulent flow. It is greater than 4000. So this is how we solve such kind of questions. So now here, what you have to know with the formula. So now what can happen if maybe you try to increase the this viscosity, okay, and the velocity, what will happen to the Reynolds number? Okay, so those are the questions that you have to know. So these are the stuffs that you have to know. So here, what will happen is, going back to the Reynolds formula, this Reynolds formula that we have here, if we try to increase this viscosity of the fluid or the blood that we are maybe solving, it means this one will do what? Will go up, because this is what? Inversely. Okay, it is not directly proportional, but it is what? Inversely proportional. So what will happen here is increasing this, increasing the viscosity. It means you'll be doing what to the Reynolds number? You'll be doing the opposite. Okay, you'll be reducing the Reynolds number. And increasing the Reynolds number, meaning this one, of course, it is what? It is less. Okay, what happens to this one will be happens to this one, but in an opposite manner. Yeah, so this is what happens here. What if you try to increase the velocity at which the blood or the liquid is moving at? It means even the Reynolds number will do what? Will increase, because this is direct proportion. So everything that is here in the numerator, here on top of the numerator, if we try to increase them, it means even the Reynolds number will do what? Will increase. And everything that is down here, the denominator, we try to increase them, meaning the Reynolds number will do what? Will go down. Okay, so this is what happens here.